Section 8.4 is kind of laying the groundwork for Section 8.5, where we solve absolute value equations and inequalities. In this section, we're going to solve compound inequalities, and we'll spend a little time working with a couple varieties of those. Let's start with something like this right here, a compound inequality. I also call them double inequalities. So the idea here for us is to try and figure out what x is, where x could live. So let me copy this first, and then we'll work on it. It starts out as a double inequality. It should stay a double inequality. Sometimes people have the habit of changing these things to equations or dropping one side of the inequality, etc. A few things that happen to it. But for us, let's try and get x by itself. And to do that, in the middle, I'll notice that I'm subtracting 1, and the opposite of subtracting 1 would be to add 1. So I'll add 1 to all three different parts of the inequality. And that gives me negative 3 is less than 3x, and that's less than or equal to 12. Okay, not bad. But we still don't have x by itself in the middle. So what else do I need to do? Yeah, divide by 3. X is being multiplied by 3. The opposite would be to divide by 3. So let's do that. We'll divide by 3. And then we end up with negative 1 is less than x is less than or equal to 4. Yay. Now on your handout, I left us a little bit of room to graph this. So let's graph it. So I want negative 1 is less than x is less than or equal to 4. So let me kind of estimate that negative 1 would be right here. 4 we don't have to estimate. But what kind of dots am I going to put at negative 1 and at 4? Good. Open at negative 1, solid at 4. So open here, solid here. And just connect the dots in between. Whoops, I didn't mean to overshoot that there. Now what happened to me once when I was practicing this kind of stuff on the homework that you face is that I entered things the wrong way. I just solved it. I entered it like this. If you look carefully, what they're asking for in the problem set, they want you to solve things and answer an interval notation. So what would be the interval notation for this one? From what to what? Parentheses, brackets. Andy? Perfect. So negative 1 with parentheses and 4 with a bracket. Perfect. Thank you, sir. That's the answer that Newton's expecting you to input. We're okay with the first one. Let's try another one right here. So I'll copy that one over to here. Nine is less than 3x plus 6 is less than or equal to 15. Now there's a couple ways you could solve this one, but I think the way that most people would work on it is to first get rid of the 6. So I'll subtract 6 from all three sides. 3 is less than 3x is less than or equal to 9. Then what? Yeah, divide by 3. All right, so everything here gets divided by 3. And we end up with, let's see, there should be a 9 here. My bad. 1 is less than x is less than or equal to 3. Okay, so kind of similar to the last one. And let's see what happens when we graph it. So it's going to be a hollow dot on 1 and a solid dot on 3. So hollow on 1, solid on 3. Kind of a short graph here for us. Like that. Yay. Now the important thing, of course, is the interval notation. So what's the interval notation going to look like for this one? Yeah. All right, Takara. 1 parenthesis and 3 bracket. Kind of remind me of the old joke. An English professor gets mad at one of her students because he's text messaging and glares at him and says, "You, give me 2 pronouns." The student says, "Who? Me?" All right. Hey. All right. Good shot. All right. Anything on that one? All right. See, it's warming up on you. That's good. We're going to jump down here for a little bit and work on these 3 because they look a little bit different. It's in their way, they're kind of similar to the compound inequalities that we just dealt with, but we're working with something that's the intersection and. And when you're solving things that have to satisfy this and that, we're looking for where things overlap, the intersection. So and, let me write it this way. And I'm going to write a triple equal bars. That means is equivalent to intersection for us. So and is equivalent to intersection. So I've got 3 different variations of kind of these same numbers and inequalities, but there's subtle differences that are going to make them illustrative of different things. Let's start with this first one, and I'll graph it. This one with a green pen, and this one with a blue pen. Oh no. Alright, my blue pen is lost forever. So I guess we'll do that one with a yellow pen then. Okay, so for the first one, I've got x is less than 5. So it's going to be everything up to 5, but not including 5. So I'll put a little hollow circle here, and I want everything to the left. How about the next one? X is less than or equal to -3. Well, I wish I had the blue one still. In this case, I'll start at -3. Yeah, this isn't really showing up too good. Start at -3, and I want everything which direction? To the left or to the right? To the left. Guess we're going to do that one here. So less than or equal to -3. Now keep in mind what you're looking for is where things overlap, where they intersect. So where do they overlap or intersect? Actually, yeah, where do they overlap? Yeah, they're overlapping here. Everything less than or equal to -3. James, you were asking earlier for some more practice with interval notation. Here we go. If I want to describe this set in interval notation, remember interval notation is always the left-hand endpoint to the right-hand endpoint. What's at the left-hand endpoint of this interval? Yeah, -infinity. -infinity to -3, because we're looking for where they overlap. They don't overlap here. They overlap here. Now the important question is bracket or parenthesis? Bracket. Thank you. So there you go. So that's the first one. Let's try again with this middle one. Are we okay with this one? All right. Let's try with the middle one. So let's see. Again, I'll use green for one of these. I'll use green for this one. X is greater than -5. So hollowed out on -5. What way am I going to draw this graph? To the right or to the left? To the right. So everything to the right. Okay, so everything to the right there. And then I also want x is less than or equal to -3. Let's try this in red. So that's going to be a solid dot on -3. And which way is the arrow going to go? To the left. You know what? Let's see. Will this work better? Yeah, this one might work better. So we'll do this one in blue. We're looking for the intersection. Where do these things overlap? Actually, everything between these two, right? So between -5 and -3. Everything between these is where these things overlap. In terms of interval notation, what would that look like? Matt?
Parentheses, -5, -3 brackets.
Perfect. We're not including the -5 because there's a hollow dot here, so they don't really overlap there, but 3 is included, so 3 is part of the intersection. -5, parentheses to -3 bracket. Thank you. There's one more case that we're going to look at with these two numbers. So this last one, again, x is less than or equal to -5, we'll do with green. And then x is greater than or equal to -3, I'll do in blue. So let's see, -5 is here. Arrow to the left. And then -3. Which way does the arrow go on this one? To the right. So let's draw this out to the right. Yeah, this should be a solid dot. Thank you. Yeah, as a matter of fact, both of them should be solid. Does that affect our answer at all? We're looking for the intersection. Do these overlap? No. So the fancy math way to say that there's no intersection, that there's no overlap, is with a null set. A circle with a little slash through it. And when you answer on Knewton, there'll be something on the palette there that allows you to put in this null set. You might have to change the palette to sets or something like that, but you should be able to input the null set there. So, okay, so different things that can happen. Here, the first one, they overlapped here. Here they overlapped in the middle. Here they didn't overlap at all. Let's do one like that with one of the ones up above. And I think I only want to take the time to do this one right here. So let me copy that to one of our pages here. We'll work on it. So we've got x over 4 is greater than or equal to -1, and -4x minus 4 is less than or equal to -3. So we need to solve both of these and see what happens. The first one's a nice little reminder about working with fractions. What should we do with that fraction there? Thank you. Well done. Multiply both sides by 4 to clear out the fractions. So let's do that. Multiply that by 4. 4 and 4. And I end up with x is greater than or equal to negative 4. Cool. We're done with that one. At least until we start graphing it. Over here with the other one, we need to solve, so a little bit of work to do there. I'll add 4 to both sides. You get negative 4x is less than or equal to 1. Then what? Divide by negative 4. Ah, well done. When you divide by a negative, you have to reverse the direction of the inequality. You got to flip that sign, so it's going to be x is greater than or equal to negative 1/4. So those are the two inequalities that you end up with. X is greater than or equal to negative 4, and x is greater than or equal to negative 1/4. So you're looking for where both of these things overlap. Let me see if this one's going to work good enough. Can you see that yellow pretty good? Yeah? Okay. And let's see, we'll also see if the blue works. All right. So we'll try and do both of these in those colors. Yeah? Which one? This one? This one. Well, when we divided by negative 4, that's what flipped the direction of the inequality. So that's that extra little annoying step. Sometimes we can avoid it, sometimes we can't. I do try and avoid it when possible, but here it just wasn't worth the effort of avoiding it. So, but thanks for checking me. Appreciate it. Okay, so let's graph these, and we'll go back to our handout to graph these. So let's bring it down to here. X is greater than or equal to negative 4. So that'll start here. And before anyone busts my chops on this again, let me put a solid dot. There we go. Solid dot, and that's going to be an arrow to the right. I'm going to hold off on that for just a second. I want to draw the other one. X is greater than or equal to negative 1/4. So 1/2, yeah, somewhere about here. Arrow is going to go to the right. Here. And then the arrow is going to go to the right here as well. So we've got negative 4 and negative 1/4. Where do they overlap? If you had to describe where they overlap, where they intersect, what would it be? Yeah. Greater than negative 1/4? Could it equal negative 1/4? Do they overlap at negative 1/4? Should I use a bracket there? Yes. Good. So in terms of interval notation, it would look like negative 1/4 in brackets to positive infinity. Left-hand endpoint to the right-hand endpoint. Smaller to larger. Always in that direction. Okay. I think that's some pretty good practice with the intersection part. We're going to move on to the union unless there's some more questions about the intersection. We're good there? All right. For the benefit of my viewing audience, there was a resounding yes from everybody. I just muted it. So, okay. Let's take a look at some other possibilities. Or means just what it is. Or. This is kind of like union. You're set building. You're adding things together. So it doesn't matter which one of these you're in. If you're in one or the other, you're in the union. So let me do a couple examples with this. I think I'm going to change this up just a little bit for the first example. We've still got some more blank graphs here to use. So for this first one, let's do x is less than -3 or x is greater than or equal to -1. So I'll put that one here on the back side. X is less than -3. Well, it's going to be a hollow dot on -3, and an arrow goes to the left. X is greater than 1, greater than or equal to 1, is going to be a solid dot. And again, draw the arrow. This time it goes to the right. If we were looking for the intersection, there wouldn't be one. You just write null set. But we're looking for the union. So if it's in one or the other, it's in both. What we need to do is we need to describe what we see, what's graphed. And what's graphed really lies in two sets. So it would be -infinity to -3 union 1 to infinity. So that's both. Unlike the intersection, you're not looking for where they overlap. You're just looking to describe anything that's graphed. Now, the original problem for this looked a little bit different. The original problem was x is less than 3 or x is greater than or equal to -1. So let's see how that would change things up. Again, you're looking for the union of these things. So x is less than 3. That'd be a hollow dot here and an arrow to the left. And then x is greater than or equal to -1 would be a solid dot and an arrow to the right. The tough thing to do is to look past the fact that, gee, these overlap. We're not looking for where they overlap. You're just looking to describe, well, what's graphed one way or another. And when you look for what's graphed, what do you see? Well, everything's graphed, right? I mean, is there a number that's not graphed on one of these or the other? Or both? Exactly right. This time it's going to be -infinity to infinity. Perfect. And let's see. Let's do one last one. And I'll kind of keep it simple. The idea extends to some of these other problems like this one. But I want to get you out of here. So x is greater than 0 and x is greater than or equal to -5. So x is greater than or equal to 0. X is greater than or equal to -5. So again, we'll keep these kind of color coordinated. X is greater than or equal to 0. Do that one in yellow. X is greater than or equal to -5. Do that one in green. So everything to the right of 0 second graph going to look like? Thank you. Everything to the right of negative 5. I think union is harder of the two of these. So the union, again, you're looking for, gee, well, what's graphed? It's not the intersection. It's not where they overlap. It's just anything that's graphed. How could you describe what's graphed? Yeah. Yeah, pretty much greater than or equal to negative 5. Exactly. It's everything greater than or equal to negative 5. In fact, we don't even really need that part, although it's part of the problem. It does end up to be negative 5 to infinity. It's really everything to the right of negative 5, including negative 5. So, kind of strange, but that's the way the one worked out. The homework will be on Newton. I'll probably extend that to give you a week. Any wrap up on that? Any final thoughts? Okay, see ya!